I want to welcome you to the expert breakout session for the Enterprise Security Summit, and this is the session for Akana. And with us this morning, Ian Goldsmith, Vice President of Product Management at Akana. Ian, welcome back.
Hello, Vance.
We're really glad to have Ian with us this morning. He is a real security guru with a focus lately on digital business technologies, particularly APIs. He is a former Vice President for Technology Strategy at Critical Path, where he drove identity management and wireless product strategies. And he's also successfully completed several cryptography and secure messaging projects with U.S. and international defense agencies. So he's really got a terrific background in very ironclad security issues. In his session this morning, Deconstructing API Security, Ian will tell us how companies are striking the balance between the need to keep APIs flexible and accessible, yet protected. He'll take us on a tour of the top security threats to APIs, how to ensure an API you create and publish will be safe, and he'll also share insights from an API security survey Akana recently conducted, as well as a tour of the Akana API security portfolio. So a terrific agenda in this session. Just a quick reminder before I hand it to Ian, if you haven't already done so, you can download Ian's slides just by clicking the button under the viewing area. You'll also see he and his team have made available some terrific white papers and data sheets, other supplemental downloads. They're all available for here right now without any extra registration. And we love your questions. So to communicate with Ian, just pop something into the submit a question box. Now, Ian, let me hand it to you and tell us about deconstructing API security.
Thanks, Vance. Well, as Vance said, I'm Ian Goldsmith. I own products for Akana. Akana is a leading provider of enterprise API solutions with a very strong focus on security. Personally, I've been in the security industry for a very long time, a little more than 25 years now, which is kind of hard for me to say. And I've seen a lot of change. A lot of things have happened. The way that the industry thinks about security has changed significantly, and APIs are changing that all over again. What I'd like to do in this session is very briefly talk about why APIs are important, what companies are doing with them, and then a little bit on why API security is important. And I want to spend the bulk of my time with you guys talking about what you have to do to ensure the safety of your APIs and how API security differs from traditional enterprise security and web security. And in many cases, it doesn't differ that much. There's a lot of similarity. That's really the focus of this session. You can see from the slide here that I have the Twitter handle API Builder, and I also blog quite a bit on blog.akana.com. Okay, so why APIs? What are you trying to do as an enterprise with APIs? This slide kind of captures one of the foci for APIs, which is the external end of things, extending your digital ecosystems, one of the key parts of digital transformation. And that's all about exposing core business capabilities to partners, customers, and increasingly employees. So what we're trying to do here with APIs is to find new business opportunities and better execute our existing business opportunities. And you can kind of think of it in terms of the transformation that the advent of the web in the late 90s created. There are companies that didn't get on board with the web economy and disappeared. There are companies that leveraged the web economy heavily and became very big, very strong organizations. Not just talking about tech companies, I'm talking about traditional businesses that transformed radically through the web. And right now we're seeing APIs doing exactly the same thing. If you're not getting engaged in the API economy, you're likely to be in a lot of trouble in a very short space of time. As I said, that's one half of it. The other half of it is that APIs are increasingly being used inside the enterprise as part of internal digital transformation initiatives. We saw a lot of talk about SOA and service-oriented architecture, the use of web services inside the enterprise as EAI type technologies, as well as the external EDI type stuff. And increasingly, we're now seeing APIs taking over the role of SOA inside the enterprise. And there's also a lot of discussion around things like microservices, which we can get into, but we won't have time for that today. So the other side of what you're trying to do with APIs is to leverage your developers and your partners' ecosystems. That is leveraging the developers that exist out in the enterprise, inside your company, inside your partners' companies, and in the wide world, trying to find ways to innovate outside your business. So how do you engage people with your products, with technical capabilities that you offer, and allow people to find new ways of doing business with you? In some ways, you can see your business changing dramatically. And in fact, the next slide has a pretty good example of that, which would be Netflix. Lots of ways that you can use APIs to drive your business, but Netflix has kind of been the poster child for APIs, with the huge transformation from being a logistics company, essentially shipping DVDs to your doorstep, to a streaming media player, and now considered one of the larger networks and content providers in the industry. And a lot of that was driven by the publication of a set of APIs that allowed customers to much more easily interact with Netflix, and really allowing customers and external developers to completely change the way that Netflix did business. Quite an amazing story, but that's kind of by the by. What we're really here to talk about is the security aspects of APIs. So suffice it to say that having APIs are important. If you don't have APIs, you may be in a lot of trouble. So think about that. So API security, what are we trying to do here? We're trying to ensure that the APIs that we publish are safe. Publishing and exposing APIs opens your enterprise to a lot more threat that you may not have considered yet. So let's talk a little bit about that. About a year ago, we ran a survey, asked a bunch of our customers and a bunch of people in the industry in general what their thoughts were on API security in general. So this question was kind of interesting. Do you have processes in place to check if the API consumer is handling the data and API securely? The API consumer in this context is a developer. So the developer community that is leveraging your APIs, do you as an API provider have a good understanding of how they are dealing with the data that you're exposing through your API for them? 30% of the respondents said yes, they did. I suspect they may be a little delusional. 60% said they didn't, and the 10% that said not applicable probably means they don't have an API, so we can stop worrying about them because they'll be out of business soon. So moving on to what their primary concerns around security were. And this slide's interesting really because it's the same set of concerns that people have around web security and enterprise security in general. And that's absolutely right. The concerns for APIs are really minimally different than the concerns you should have for web security. And we're going to talk a little bit about the OWASP top 10 and how that applies equally to APIs as it does to web. The one big difference that you see here is around content threat. So things like XML bomb, JSON schema are big concerns for APIs, as they were in the web services realm. And make no mistake, there's really no significant difference between JSON schema threats and XML bombs, other than the fact that JSON is a less well-structured, or to be accurate, JSON schema is a less well-defined entity than XML schemas. So it's a little bit more difficult to validate a JSON document against a schema than it is an XML document. Now that is changing. The industry is standardizing JSON schema, and there are schema validation tools available. But at the end of the day, the risks in content threat around scale and size of document, width, breadth, depth, all the things that can cause the parsers to fail are still out there. In the case of JSON, the JSON parsers, because it's a younger technology, are not as well established and not as well validated as some of the major XML parsers. So there may be a little bit more risk involved in JSON than there is in XML, although again, that's changing pretty quickly. Then of course you got distributed denial of service, injection attacks, all of that kind of stuff. A lot of different attacks out there. We're going to talk about what a lot of these things mean. But really this slide was just to kind of highlight what people worry about when it comes to the enterprise security implications around APIs, and really to highlight that there's not that much difference in the things that people are concerned about when you talk about APIs from the things that people are concerned about with other technologies. And that's quite correct. Okay, so how has security changed through digital channels over time? We'll keep this very simple on my highly simplistic diagrams here to keep things light. So back in the good old days of client-server web apps, you didn't have a lot of options for how you got to applications. There was no programmatic access. Basically, you could provide security through network isolation. So I can publish a web server in a DMZ and ensure that only certain network enclave can access it if I were able to do that. If it had to be exposed to the public internet, obviously I had to have that web server accessible to the public internet, but then I could use network security to ensure that the web server only had very limited access inside the enterprise. We also, dealing typically with a more limited set of users, I could control who was coming in the front door essentially. So I didn't have to worry too much about locking the doors inside my application because all I really had to be concerned about was front door security. And along came web services, sort of part of the whole SOA initiative, SOAP, WS Star, all of these kind of things. The enterprise sort of opened up. Now, bear in mind that originally, when I say originally here, we're really talking 2000, 2001, 2002. The idea behind web services and SOAP was that web services were going to be what APIs are today. That is, they were going to be this idea that you as an enterprise would surface core business capabilities via web services and publish them for anyone else to consume. And it was great. It was a really good idea. There was going to be this thing called the UBR, or the Universal Business Registry, which was basically a cloud-based registry that would allow you to look for business capabilities and connect to them. Unfortunately, it all started to go a bit pear-shaped when we realized that there were some security concerns and that SOAP, as it stood, was missing some key features. And by the time the standards communities and standards bodies got involved and created the huge set of WS Star standards, so WS Security, WS Policy, Federation, Reliable Messaging, et cetera, SOAP had become so complex that there were really two problems. One, it was really difficult for anyone to use. And two, even if you could use it properly, it was borderline non-interoperable because of the range of options in configuration. So, for example, you really had to have a huge amount of expertise to get an application built using Microsoft's WCF technology to communicate with a server written in WebSphere. The implementations of the WS Star stacks, while standards compliant in both environments, were very different and configured very differently. It was kind of challenging. That's a bit of an English understatement there to call it kind of challenging. It was almost impossible. So point A around it being very difficult to use in some ways helps security, but that's not necessarily a model we recommend in the enterprise security realm. But suffice it to say that the challenges around securing web services made the adoption of web services very difficult. So just as an example, this is what a WS policy assertion looks like. Now, this is just the assertion, not even the WSDL, not the definition document. This would be one policy that would specify, in this case, how you would use signed SAML assertions to authenticate an application. And it would be one part of many elements that would exist within the definition document describing how to secure the application. It became a nightmare, very, very hard for anyone to use or manage. So now along came APIs. And now make no mistake, APIs are services. APIs are web services. There's nothing in the definition of a web service that says it has to be SOAP. An API is programmatic access to an application over a network. And that's exactly what a service was. Now, when we talk about APIs, we tend to think about RESTful, so services over HTTP, HTTPS, using JSON content with following the fielding model that describes a resource-centric approach to things. A lot of APIs are well executed and are written that way. Some are not. There are things like transactional services where the RESTful model is not terribly useful. It's difficult to implement a pure RESTful model in a transactional environment. But that said, APIs have considerably disrupted how and where information is accessed. Applications that you use on a daily basis are almost certainly API driven. If you use Facebook, that is a JavaScript, HTML5 client running in your browser using a set of APIs to communicate with the Facebook servers. Same for Twitter, same for Microsoft Outlook, same for pretty much any application you use today, whether it's web-based, client-based, mobile phone-based. They're all consuming back-end capabilities via APIs. Now, when you really start to get into the mobile world, you realize that mobile applications and social apps really can't deal with complex PKI environments and certainly can't handle WS security, sophisticated XML processing. These are things that are very hard to do in the amount of application real estate that you have on a mobile device. And so that's where the modern approach to APIs with easy access for developers to the API, human readable content, a lot of things designed to drive the adoption of the API have made API so successful. But at the same time, these very things that make API successful, human readability, good documentation, ease of access, developer portals, etc., the accessibility of your APIs make the APIs themselves vulnerable to threats. So what are the key threats? Well, I come back to the OWASP top 10 again and again. The Open Web Application Security Project, it really is designed to look at web applications, which 10 years ago, 5 years ago, meant a browser consuming content from a web server. Increasingly, that's now talking about API-style access to various different things. And there are a lot of things that are API only relevant in this list now, or some things, but there are still a lot of things that are common across all types of web applications. I mean, some of the big things that you start to see are the risk of injection for APIs. So it's one thing to have a form on a website and ensure that you don't allow someone to enter JavaScript into that form that can then cause problems in the back end. It's another thing if the web application in the browser is packaging up the information presented in the form and submitting it to a backend via an API. You've got another level where you have to protect. You can't just protect in the client code itself. You have to have protections in the back end to look at the content coming into your API and ensure that you're protecting against some of these things. Things like cross-site request forgery are a big problem when it comes to the world of APIs, and really not such an issue in straightforward client-server web apps. I'm not going to take a great deal of time going through all of the different issues in the OWASP top 10. Suffice it to say that they're there, they're well documented. Go look at the OWASP project. And these are things that basically require discipline for both client and API developers to ensure that you're effectively protecting against. We put a huge amount of time in at Akana with things like automatic source code scanning to look for vulnerabilities whenever we build the product. In fact, that's part of our continuous delivery process. Our build processes automatically do these scans. Another thing that's kind of important is PCI. And PCI is kind of an interesting thing. It's the payment card industry standard. When we talk about PCI and security, we're really talking about PCI DSS, the data security standard, currently at version 3.1. And that's really important because the APIs are part of your e-commerce platform, and credit card transactions are happening through and over APIs. And increasingly, we're seeing API-driven payment platforms that are really changing the way that businesses work and changing the model. We're seeing disintermediation of the credit card networks and all sorts of things. There's a huge amount of disruption in that space, and it's getting really interesting. So the PCI DSS standards are changing very quickly to continue to evolve around that. Now, one thing I want to highlight on PCI is that a product cannot be PCI certified. PCI certification is something that applies to a service that you offer. So we Akana run an API management platform that has a level 1 service provider certification under PCI DSS 3.1. If you are delivering a product to somebody, that product cannot be PCI certified, only a service. It's a very painful audit that you go through. Kind of think of it as a proctological exam where most of the PCI certification is about policy and process and ensuring that your company is operating the right way and is doing the right things. Okay, so enough about why you need to secure APIs and what the threats are. Let's take a quick look at the 6 main techniques for securing APIs. And I've got a slide on each of them. So starting with authentication, authorization, single sign-on, you have to control and restrict access to your APIs and make it easy for people to use them and yet secure at the same time. There are 2 classes of user for APIs. There are the developers that are writing applications that are going to consume the API. Then there's the end user of that application. Now, something that's come up in the last couple of years, a little longer than that really, is OAuth. I mean, OAuth is kind of interesting because what it really does for you is it allows you to delegate constrained access from one application to another. So what does that mean? Well, it means that the user, that would be me, as an owner of a resource, maybe my bank account, I'm using a client application and I can delegate to the client the authority to act on my behalf when interacting with the resource. So there are some really interesting things going on there. One of the beauties of OAuth is that it means that a client application never has to see the password for the resource server, for the service that the user is actually using. So you've all probably seen this when you use Facebook as an authentication system or Twitter. I'm going to use a particularly interesting example and talk about Hootsuite. Hootsuite's interesting. I don't know if you know what it is, but basically it's a social media management platform. It allows me to manage the distribution and publication of content across multiple social media channels. So what's interesting is that Hootsuite basically acts as a client for Twitter, Facebook, Google, other social media platforms. And what I can do with Hootsuite is I can sign in with Facebook. So it means I'm logging into Hootsuite, and Hootsuite is accepting Facebook's word for the fact that I am who I say I am. So basically, Hootsuite is delegating authentication to Facebook. And that's pretty common. You see that quite a bit. You can use a number of different applications, allow you to log in using Facebook. Now, in the case of Hootsuite, it takes it a little bit further because Hootsuite is then able to act as if it were me when interacting with Facebook or Twitter, for example. So Hootsuite can tweet on my behalf. And so there's another level of access there. So when I first log in, when I first go create an account, say sign in with Twitter here, I get a page published by Twitter. It's got the Twitter logo. It's on the Twitter URL. And I'm authorizing Hootsuite to use my account. And basically, Hootsuite is requesting a number of different scopes, is the technical term, but basically privileges from Twitter. And it's saying, okay, I want to be able to read tweets. I want to look at your following and add people to who you follow. I want to update your profile, post tweets for you, and access messages. Basically, I'm saying Hootsuite's going to be a Twitter client that can do a whole bunch of things for me. And I give it my Twitter username and email and tell it to remember me. Now, Hootsuite will never see my password. This page is published by Twitter, and it's basically Twitter authorizing me to do a whole bunch of things. Once I complete that step, I'm then logged into Hootsuite, and Hootsuite's able to do stuff with Twitter on my behalf. Pretty interesting concept. But the beauty of OAuth in all of this is that you as an API provider are essentially taken out of the loop of having to worry about authentication, authorization. It's all handled by the backend application and delegated to the user. You don't have to provide a help desk so a user can call up and say, hey, I kind of need you to give my gardener access to my lawn care information. You can grant that access yourself using OAuth. Kind of a crass example, but you get the idea. Now, of course, unfortunately, OAuth started off nice and simple. OAuth 1.0, really 1.0a, was a fairly straightforward specification, relatively easy to implement. But then the committees got involved and it became much more complex. OAuth 2 is difficult. It's very, very powerful, but it's complicated. And there are a lot of things that you have to do and have to be able to understand as you get into that. And again, that's where companies like Akana come in. We provide technology and guidance to help you implement OAuth effectively. We provide a set of products that allow you to add OAuth to your APIs and do sort of things like that. The second thing I want to talk about is licensing and app access control. Basically, this is developer-centric access where I'm saying, okay, I have an API that does lots of different things, and I've got different constituents of developers who are going to be interested in different bits of it, writing apps that are going to need to consume different parts of the API. So you need some kind of mechanism in your developer portal and in your API gateways to control what developers can see and what apps are able to access once they're consuming the API. Basically, provisioning process, so a developer can say, hey, writing an app, I need it to be able to access X, Y, and Z, and a gateway that can authorize that app to have that access. So those are kind of the two levels of authentication authorization. Level one is end user, and in the API realm, it's really all about OAuth, really is. Particularly now when you think about OAuth with JART, which is JSON Web Token, and OpenID Connect, which is an OAuth profile that provides an easy way of surfacing authentication information via OAuth. So that combination of end user and app identity and licensing really gives you all of the access control you need. So then you get into kind of the heart of things. You get into the guts of what you're passing back and forth across the API. And you're starting to talk about messaging parameter security. So how do you secure API parameters and content? There's a relatively new standard out called JOSE for encryption and signature of JSON content. You've got a lot of use of HMAC which is hash-based message authentication code for securing parameters, more commonly used in headers. So you see a lot of HMAC security in the authorization header, for example. But you do see HMAC security on individual query parameters and path parameters as well. So there's a lot of different technologies and techniques for securing message content. Far and away the most common is HTTPS. HTTPS is good enough in most cases. Basically, with HTTPS, you're securing the channel between the client, browser in many cases, and the API itself. Message security takes it a step further by allowing the client to encrypt and sign elements which remain encrypted and signed all the way through to a backend application, even as they traverse proxies and other different network entities. Whereas with HTTPS, you're typically having to decrypt it at various points along the way. So it's a sort of a different approach. Really, with JOSE, you've now got a world where API security, and particularly JSON security, is on a par with the capabilities that were enabled through WS Star. And in fact, they've done a nice job of keeping it a little bit simpler, so you really don't get buried in WS policy, unless, of course, you're a masochist and you want to. Okay, so moving on, threats. Threat prevention, very similar threat prevention to the same kind of technologies and techniques you need in web security. So you've got denial of service, distributed denial of service, all the injection stuff, cross-site scripting, CORS, CSRF, and then you've got all the usual network stuff. Do you want to prevent access from known threat sites in Russia and China, for example? And a lot of the time you kind of defer a lot of the network level threat prevention to specialist tools like Alert Logic and things like that. Particularly when you start getting into cloud-based deployments, you typically hope that your cloud vendor uses that kind of stuff to keep their system safe. And we certainly do in the SaaS platform that we provide. And I think you'll find that most cloud players do. Content threats is really all about ensuring that you prevent malicious content from making it through your API to your backend. And that, of course, is all the injection stuff fits into that, a lot of the OWASP top 10, but there's also virus. How do you scan API content for viruses? And again, your API management platform should be able to do that for you. It's something that we do as part of our platform. And then finally, we get into quota management and rate limiting, which is really about ensuring that you can protect your backend application in some ways against success. What if you publish an API and it goes viral and all of a sudden your business grows from having to process 10 transactions a second to needing to process 1,000 transactions a second. Well, that's all well and good, but you can't have that bring your back-end application down. So an effective API management system can allow you to ensure that requests coming from critical applications are going to be processed, while requests coming from people that may be a lower priority for your business can be limited and throttled as needed while you work on obviously increasing the capacity of your back end. So being able to understand which applications are consuming your traffic, provision capacity across multiple different applications, and govern which applications get what level of access is kind of important. And being able to do that in a distributed global realm is very difficult. So we have a SaaS platform distributed across the globe, different data centers in the US, in EMEA, and in APAC. And we can manage quotas for APIs distributed across all of those environments. And all of that is handled by an API gateway. Lots of content about API gateways out there. Check out ours at Akana.com. There's a lot of capability there. It's one of the things that distinguishes us as a platform. I got a couple of minutes left, and I just want to talk briefly about managing and automating security and what that looks like. I really want to talk about it because I enjoy this slide immensely. As DevOps comes into focus inside a lot of large enterprises, you have to understand that this is how security people tend to think of DevOps. You are walking around behind that mythical beast, scooping up what it leaves behind. So how do you ensure that security becomes an important part of your continuous delivery process to ensure that an aggressive push towards DevOps doesn't end up in disaster? Well, you govern, or given that that's considered a rude word these days, you manage your development and deployment processes with security in mind. So you have to integrate your API initiatives with your DevOps platforms. You have to be able to define and track versions and dependencies throughout all of your processes in a way that's integrated with all your development tools, whether that is SVN and Clips, or whether you're talking about things like Cloud9 and GitHub and Chef. It really doesn't matter. You have to ensure that you consider all of the sources of change and that you understand and track the implications of that change across the life cycle of your applications. And you have to be able to manage user and app onboarding. So you have to be able to collect and gather information about apps. Now, bear in mind here that one of the main things you're trying to do with APIs is to surface key capabilities for your business to new constituents. But at the same time, you can't open the door wide and say, hey, come on in. If I'm exposing a payment platform and my model is to go after merchants and get merchants to use my payment platform, I need to know who those merchants are in some level of detail. So I need to be able to onboard users quickly and easily so it's not a burden to the user, while supporting all of the regulatory and other business requirements that I have. So automating the governance of the user and app onboarding process is critically important, and ensuring that you have approvals throughout all of your SDLC process so that you can control who's doing what. It's kind of like something they talk about a lot is trust with verification. So in DevOps, you need to be able to verify that security process is being followed appropriately without getting in the way and slowing things down too much. Anyway, end of my particular soapbox for the day. If you need more information on any of this stuff, come check us out, Akana.com, resource.akana.com for specific white papers, various other things. Bunch of stuff on blog.akana.com, and then you can check us out in various different social media channels as well. And with that, this concludes my formal remarks. I'll hand this back to Vance and see if we have any questions.
Ian, what a great session, overlooking the general threat issues and landscapes that's out there for APIs, as well as taking a look, drill down into what some of your customers are doing to ensure API security across a lifecycle. Really terrific session.
Thank you.
You know, Ian, so many different types of questions and comments come in. Let me start with just kind of a level set question. Given there are hundreds, if not thousands, of APIs that have been built in a rush out there in the industry, and maybe only afterwards IT or developers think of working to put a gateway or an identity manager in front of it, it seems that there might be some vulnerabilities or at least some things that folks hadn't fully thought through when it comes to an API strategy or certainly implementing API security. Are there factors that you think that people should either be worried about or should consider that they could do in the future to keep their APIs safe from threat?
That's actually a great question. It's something that I think we struggle with a little bit in the API management space. You've got a couple of different classes of API out there, right? You've got applications that were built API first. And in fact, you've got entire companies that were built API first. And in those cases, the security tends to be built deeply into the API itself because the API is the application. So they're kind of in better shape than companies that sort of started with an application, surfaced a few services off it, stuck a gateway in front of it and said, okay, now my gateway is creating an API and publishing it. Now let me secure that. So the second approach is very common. There's absolutely nothing wrong with that approach. We have a lot of customers doing just that. You have to be careful to ensure that you've got the right gateway that's implementing the right kind of security and that you're using the gateway for the right things. So what I mean by that, and I'm going to try very hard not to climb too high on my own soapbox here, but I'm a huge believer that entitlements belong inside the application and not inside a gateway or a proxy. So what I mean by entitlements is it's one thing to have a mobile app that is authorized to access a banking application, but that mobile app should not be making the determination about which bank accounts it's allowed to access. That should be done by the back end. And that's kind of what I meant earlier in the presentation when I talked about in the old days, you didn't have to worry about locking the doors inside your application. You only had to worry about your front door. Now you have to worry about the doors inside the application too, because those doors are often exposed via services. So you've got to make sure that you have good authorization processes throughout an application. And that gets way worse when you start thinking about microservices, by the way.
You know, Ian, this is such a rich topic, especially given your expertise. I'd like to drill down just a bit more to another level and give our attendees some benefit of your experience with customers. So let's kind of follow through a profile or a scenario. Oftentimes we'll see a developer who wants to build an app quickly. They tend to begin by asking a back-end data owner if they could surface a data or service through an API. They could end up building that app faster. And the owner may not know much about security, but he certainly understands how REST or JSON might work. So he might create that API to let that developer access that resource. So they're kind of in simpatico, but neither one of these folks may know about security. So a couple of questions here. Is that a common profile? And if so, how does Akana help the CISO or security professional keep this kind of interchange between the front end and the back end safe?
I think it probably is a very common profile. This is, I think, the really hard role that security organizations and CISOs in particular are placed in right now, where you don't want to slow down innovation, but at the same time, you have to protect your company against the risks and threats of making these kind of mistakes, which can be really severe, by the way. I won't name them, but a large retailer and you lose a few million credit card numbers, that's going to cost you a lot of money. So we provide technologies that API developers are going to want to use to surface their APIs and publish them, make them easier for people to use. And in the process of using those tools that we provide, so developer portal, design tooling, gateway, the enterprise architecture team, or your COE, if you have one, will immediately and automatically gain insight over what's being published. And also, because that tooling provides out-of-the-box security policies, it makes it much easier for an application owner to go, okay, well, I'm surfacing this application. Let me look at it and see, oh, man, yeah, this is kind of delicate. I've got some payment information in here. I've got some personally identifiable information. I got to be careful not to surface. So that means I'm going to have to pick the security policies relatively carefully, but I see that they're available to me here, so I can just go ahead and pick them out of the box, add them to my API, and I'm done. So by making it easier for people to consume APIs or to publish APIs with security, we make it much more likely that the appropriate policies will be applied. And at the same time, we provide visibility to people who need to know that there's that API out there now. By providing tooling that makes it much easier for you to publish APIs, and also by providing a gateway through which all APIs can be forced to be published, so we can make sure that all incoming API requests hit the gateway. So if your API isn't published through the gateway, you know, no one can consume it. Then that gives us visibility into all of the traffic that's coming in and makes it very easy to understand where risks may apply. And because, again, our API gateway out of the gate has a bunch of threat protection attached. So, for example, if you're using a SaaS platform, you're already wrapped around by intrusion detection software from Logic. So we can understand where threats are coming from and can protect you.
You know, Ian, a great discussion, great insight. And I see we're just about out of time, but let's see if we can tackle one or two other questions or comments. Earlier in your session, it was brought up that you mentioned hacks or the theft, as you mentioned the case study of the credit card numbers. Here's a question. I've seen a lot of news about hacks into what would seem to be very secure systems, even ransomware. How many of those might be triggered by unsecure APIs?
I think that pretty much any attack against a website at this point is attacking an API one way or another, because the website is almost certainly enabled via an API. It's very difficult to find a large-scale web presence that is not backed by APIs. Whether the attacks are against the web server that sits in front of the APIs or directly against the APIs themselves is really a question of how well architected the web application is. Certainly, there are a number of attacks that are targeted explicitly against APIs, but there are still probably a greater percentage of attacks that target the front end, because the front end is going to give the hacker the clues as to what sits behind it. Just open up the Chrome Web Inspector next time you open a page on Facebook, for example, and look at all the API calls it makes in the back end, and you'll understand where the potential threat points are. Now, Facebook does a pretty nice job with its API security, so they're nice and safe, but not everyone is.
Excellent, excellent. You know, Ian, as we close, I'd like to talk a little bit about product. I know Akana has on-premise and cloud offerings for API security. Perhaps you could spend a minute or two walking us through these, and even how people could take a free trial of the Akana API security offerings.
Yeah, sure, thank you. We still deliver a lot of on-premise software, but I'd say we're cloud first. So every release of our platform is deployed into our cloud and taken into production, our cloud, before we make it available to customers. And so that's not a huge change for us, but a significant impact for our customers. We also exposed a self-service registration portal where customers can create tenants in our platform and sign up for a 30-day free trial. So just check that out at www.akana.com. Top right-hand side, you'll see a link to log in, sign up, and go ahead, sign up, create a tenant, and have a play. And love to hear any feedback on the platform and how much value people are getting out of it.
Yeah, that's fantastic, Ian. Thanks very much. As a matter of fact, we know so many of our attendees are working on API projects like the ones you described, that I'd like to put that link right here in the breakout room. We'll make sure to make it easy for folks to get in touch with you for that free trial.
Great. Thank you. Appreciate that.
Very good. Ian Goldsmith, Vice President of Product Management, Akana, thank you very much for a terrific session on deconstructing API security and giving us an overview of how to strike that balance between API accessibility and keeping APIs safe.
Well, thanks, Vince. I really appreciate the opportunity to run this session. Enjoyed it immensely, and great set of questions at the end there. Thank you.
Our pleasure, totally, our pleasure. And as we love to do here at the Enterprise Security Summit, Ian mentioned some other terrific resources. We'll put a slide up here so that you can find them easily in one quick resource. The slides, again, are available for you right away, along with some other great PDFs, all without any registration required. So thanks again, everyone.